In this video, we're going to talk about combining probabilities. Before I do that, I'm going to kind of start off with this example, and I'm going to go through a bunch of different combinations of how I could do probabilities with that, different type of combining probabilities, just kind of looking at all the possibilities. Okay, so we have a bag of prizes. There's 10 prizes, and people are going to draw them at random. Okay, so two of the prizes are yellow erasers, one's a yellow calculator, three are green calculators. Clearly, this is a bag of like teaching some teacher has done for their class. Three are green calculators, and four are red erasers. Okay, so let's find the probability of YE, which is going to be yellow eraser. So since there are two yellow erasers out of 10 total, that'll be 2 out of 10. I'll go ahead and just reduce that to 1/5. And I'll leave those in fraction form for right now. Yellow calculator. Let's see. There's only one yellow calculator out of 10, and that doesn't reduce, so leave that alone. Three green calculators. Doesn't reduce. And then there are four red erasers. That does reduce to 2/5. Cool. Okay, real quick, just gonna comment that the items that we just talked about represent all the possible prizes. And if I look at the ones that are set out of 10, if I added those up, that add up to 10 out of 10, right? 2 plus 1 plus 3 plus 4, 10 out of 10, which makes sense because I just listed all the prizes possible. Okay. Um, all right, but let's look at it a little differently. This time, let's say I'm just saying, what's the probability we're going to get a calculator? Okay, well, in that case, there's technically two types of calculators. There's a yellow one and a green one. One yellow one, three green ones. So there's a total of 4 out of 10, which reduces to 2/5. Cool. Erasers. Okay, so we have two yellow and four red. So 6 out of 10 or 3/5. The biggest odds so far. Red, just getting something red. Okay, well, technically the only thing here that's red are the erasers, so there's 4 out of 10 or 2/5. Something that's yellow. Okay, there's the erasers and the calculator, so that's 3 out of 10, and that's actually as reduced as it'll get. And then green items, let's see. Oh, there's only the green calculators, so that's 3 out of 10, and that doesn't reduce any further. Okay, there we go. There's all the possible combinations for this example, but now let's look at what we can do further than that, okay? Different type of combination. So this time, we're going to talk about the idea of drawing one item out is an or, and then talk about the probability of when you might draw multiple items out of the bag, okay? So, or means that you're allowing for two possibilities. What's the probability? So here, I'm going to give a different example. What's the probability that I buy a dog or a cat, right? Something like that. Um, and you kind of base it on the idea that you're giving an or possibility. So there's two types of or probabilities. There is the type where the items have nothing in common. When you're saying it, they have nothing in common. That's supposed to be a T. Nothing in common. Another phrase for that, the technical phrase, is disjoint. That would be like the example I just gave. What's the probability I'm going to buy a dog or a cat? In that case, they have nothing in common. You can't get an item that is both a dog and a cat. Okay, that's just impossible. But then there's the case that maybe the or does allow for something in common. Okay, which means they have some sort of overlap. All right. That overlap, by the way, is what they call an intersection. It's what they have in common. What those two sets of things share. Okay, let me give an example of that. So let's go with the buying thing. Let's say this time I'm saying the probability that I buy a book or the probability that I buy something to do with my hobby, cooking. Okay, in that case, I could end up with a book or I can end up something that has to do with cooking. However, there are Cookbooks. So it's possible that I get an item that actually kind of qualifies for both. They have something in common. Okay. That's an example of that type of or. Okay. So that does have a formula. Its formula is you add the two probabilities together when they have nothing in common. But when they do have something in common, we actually have to compensate. So this one has a different formula, similar. This formula takes the probability of A plus the probability of B, but minuses the probability of A and B. That's that overlap, the thing they have in common, something that is in both category A and category B. Okay, now, before I go ahead and try a couple examples of those, actually, here, let's just try. What's the probability of drawing a yellow or a green? Okay, so this would fall into the things that have nothing in common because we're going to classify things as either yellow or green. There's not something that's classified as both. Okay, so we're going to find or use the first formula. We're going to find the probability of yellow and add it to the probability of green. So the probability that something was yellow, I think that was looking back up here, 3 out of 10. Okay. 3 out of 10. And something that was green is also 3 out of 10. So that adds up to 6 out of 10 or 4/5. All right. Okay. This one, what's the probability of drawing a red item or an eraser? Okay, now this one, they do have something in common because there are things that are classified as both red items and erasers. They're the red erasers. Okay, so in this case, we'll have to use the second formula. I'm going to find the probability of a red item. Then I'm going to find the probability of an eraser. And then I'm going to subtract the probability of the red erasers. I'm going to write it RE like how they did. Okay. So, red item. There were 4 out of 10 red items, plus 6 out of 10 erasers. But then, technically, the 4 red erasers got counted twice. They got counted here and here. So I have to subtract that out. I have to compensate for the fact that it got counted in both of those probabilities. So that gives me, let's see, 10 minus 4 is 6 out of 10 or 3/5. Here, I'll squeeze that in. Yay. 3/5. Okay. Those are the examples of the or events for that problem that we just did. Okay, now let's talk about and. And really has two possibilities when we're talking about multiple draws. This means that you're like putting your hand in the bag and drawing a prize out and then getting another prize. So two prizes, okay? There's really two possibilities. There are the independent draws where they're independent. And then there's what's called the dependent draw. So what that means is when you're saying two events are independent, you're saying that one event happening doesn't affect the other event happening. When they're dependent, they do affect each other. Okay, so when you stick your hand in the bag and you draw out a prize and you are holding that in your hand and you go to draw a second prize, typically you're keeping the prize that you already drew out, right? So the odds have now changed in the bag. You no longer have 10 items in there. Now you have 9 items. That means the events are dependent because when you draw the items out of the bag, you do it without replacement, which makes sense. That's how you'd expect to do it. But to do independent, meaning, so how could I do drawing stuff out of the bag twice, but not affect the odds the second time? That means I need to put the item back into the bag that I drew out the first time. So that means you would have with replacement. In order to make it so that they don't affect each other, you would replace the item back into the bag, and now the odds are still the same. Okay, let's look at an example of that in a second, but really quick. It's using a probability of multiplication. Technically, it's also going to be multiplied for the dependent events, but we're going to have to compensate and change it each time because there's a condition that is being set. So this is called a conditional probability. The condition is what happened with the first draw out of the bag, okay? Or what the odds happened on in the first event, how it changed the odds in the second event. Okay, let's look at an example. It helps to look at an example. If we put the items back each time we draw with replacement, what is the probability that we're going to draw 3 red erasers in a row? Okay, so the first red eraser we draw out of the bag has the odds of 4 out of 10 because there's 4 red erasers in the bag. Okay. The second time, so we threw that red eraser back into the bag, shook the bag up, go ahead and draw again. But now it's still 4 out of 10 because we still have 4 red erasers in the bag out of 10 items total. Okay. And then if I do it a third time, it's still going to be 4 out of 10 because I keep putting the red eraser back into the bag. So the odds of getting a red eraser remain 4 out of 10 every time. Okay, so let's see. That's 64 out of 1,000, which actually reduces to 8 out of 125. Okay. If you don't put the items back in the bag, what happens? So the first time when we don't put, or when we draw the red eraser, we still have the odds of 4 out of 10. But now the odds are going to change because now I'm holding the red eraser in my hand. And how many red erasers are still in the bag? Well, that'd be 3 out of 9. There's only 9 items now in the bag. So the odds have changed for the second red eraser. So let's say I get another red eraser. So what's the probability that the third time I get a red eraser? Well, this time it's going to be 2 out of 8. And notice I'm multiplying on both of these because we're talking about and, meaning that all 3 of these are going to happen. That's an and event. Okay, let's see. Let's multiply. That's 1224 over 720. And I actually already reduced this. These both divide by 24. And I want to say this is 1 out of 30. I'm almost positive. Let's see. I can check. Yes, it is. It's 1 out of 30. Cool. All right. So the odds are far stronger that with replacement, you'll get 3 red erasers. Okay. This ends up being like if you actually divide 8 by 125, like a 6% chance. But 1 out of 30 ends up being like a 3% chance. So yeah, that's how the and works, and how you may have to take into account that the first event might affect what happens in the next event. So if it does, you have to change the odds. Otherwise, the odds stay the same. If they don't affect each other, you don't have to worry about it. And that is how we do combining probabilities.